Hi, my name is Nicole Westman-Enzinger, and I'm a professor at George Fox University. I have my email and my Twitter listed here if you wish to reach out to me. The title of this research brief in the proceedings and the study that was done is Children's Integer Division, Extending Analogies, and Direct Modeling. You'll notice I have a strike through on the direct modeling, and that's because given the limitations of a research brief, I'm going to just focus on talking about analogies with integer division today. So the theoretical framing for integer analogies comes from the wealth of literature on integer addition and subtraction, where despite your research group or your kind of approach to doing research with children's thinking around integers, there seems to be a consensus that children use analogies when they're thinking about integers. I would say that there's ubiquitous evidence in the literature of children drawing on analogies. And one simple analogy from addition subtraction for us to think about is children, the first time they see -2 plus -3, will often get the correct answer by saying -2 plus -3 is -5, because they make the analogy that if 2 plus 3 is 5, would not -2 plus -3 also be -5? And so the first time young children encounter negatives, they can solve problems like this correctly by making whole number analogies. In a study I worked on with an undergraduate researcher at my institution, we looked at the way children were making sense of multiplication, and we noticed that they also used analogies. However, analogies that they used with addition didn't always work with multiplication. For instance, -4 times -2, a student said, is -8. And they made the logical argument that -2 times -4 must be -8 because if 4 times 2, which are both positive numbers, is 8, why would not -4 times -2 also be -8? We know that's not correct, but the analogy is logical. And so this really made me curious about the types of analogies that children might construct and ways that they are productive for negative integers. So the research question today is, in what ways do 2 grade 5 children reason with analogies as they engage with integer division for the first time? So this little exploratory study that I'm reporting on is in the context of something else that I want to give a background to. I was working with 3 grade 5 students that had no prior experience with integers, so like formal instruction. Perhaps they encountered them in their world, but they hadn't had a formal experience in school mathematics with negative numbers. I had conducted a 12-week teaching experiment with Steffi Thompson 2000 teaching experiment on addition and subtraction. So I did 9 group sessions with them, 8 individual sessions on integer addition subtraction. As part of that, I was studying the ways that they were constructing meaning. I wasn't giving top-down instructional models. This is reported elsewhere. But at the end of that, I wanted to do 2 exploratory sessions, one on multiplication and one on division. So this study comes at the end of a teaching experiment where children were constructing negatives. They're kind of models for negative numbers on addition subtraction. 2 students did it, Alice and Kim, in a parent setting, and this that I'm talking about today only focuses on division. And these are the 3 division problems that were provided to the students. -24 divided by box equals -2, box divided by -3 equals -10, and -21 divided by box equals 7. I made the intentional choice to have the unknown be on the left-hand side, and I also made the intentional choice to have 2 negatives, negative, 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 and then 1 negative, 1 positive given. All right, so for -24 divided by box equals -2, both Alice and Kim make analogies for -24 divided by box equals -2 to a positive division number sentence 24 divided by 12, and their transcripts are here. Kim provides a nice visual representation here where she actually writes out her analogy. Kim says, yeah, there's both negatives. I just compared it to something easier. I just did 24 divided by 12. And Alice says, I think it's negative 12 because 24 divided by 12 is 2. These two are negative, so I thought it would have to be negative. So it's interesting because Kim's getting the correct solution with the same analogy, and Alice is getting the incorrect solution with the same analogy. But Alice ends up changing her mind to positive 12 later on through direct modeling, which I'm not going to talk about today. All right, for the next one, Alice and Kim both get the correct solution, and they both they both make an analogy to a whole number sentence. So 30 divided by 3 is 10 is what they compare. Box divided by negative 3 equals negative 10 to. Kim says you can multiply these two, points at negative 10 and negative 3 on the paper, but in a negative way, on the negative side, so 3 times 10 is 30, just add the negative symbol on it. And I guess one of my takeaways from this is that it's not surprising that Kim and Alice applied whole number analogies to this situation, because whole number analogies often work well for addition and subtraction in certain situations, like all negatives to all positives. And it also depends on the magnitude. So like, for instance, negative 5 minus negative 2 compares well to 5 minus 2, but negative 2 minus negative 5 doesn't necessarily. So like, the nuances of the number type matters. So this particular, I think this should be, these particular number sentences, they compare well to whole number analogies. Okay. All right, so let's contrast that to negative 21 divided by box equals 7. In this case, Alice answers negative 3. And even though she gets the correct answer, she's laughing because she says it doesn't make sense that a negative divided by negative would be positive. And it is really, I mean, even as mathematicians, we can see that this is quite, counterintuitive sometimes. So she writes nope, and she kind of laughs at herself. Kim gets 3, which is the incorrect answer, and she makes a joke of it as well, you can see here. And my favorite quote is she says, I'm conquering, I'm not confident. So neither one of them were very confident about their solutions, and they went on further to do some direct modeling that I won't be talking about today. But sort of my point of showing this is to kind of make an argument that whole number analogies might work well for some number sentence types, and it seems though that what would be productive here is for this negative 21 divided by 7 to make an analogy is more of an analogy to integers. So Alice says because 21 divided by 3 equals 7, so obviously that's not it because this one's a negative. She states the challenge with the structure because, well, it doesn't make sense that a negative divided by negative would equal positive. So maybe it doesn't make sense to her, so what can we do to help support her in that? But Alice does not fully articulate her analogy, but it seems like she's comparing negative 21 divided by 3 equals negative 7 to negative 21 divided by negative 3 equals. So it seems as though she's making not a whole number analogy, but perhaps an integer analogy. So here's some of my concluding remarks. Analogical reasoning has both affordances and hindrances for integer division. And there is a lot of potential for analogical reasoning for integer division. And I think the potential lies in the fact that the students were constructing it and wanting to do it. Students may need different types of supports for different problem types. And so this is sort of, I guess, my takeaway here, which is that these problem types here seemed to connect really well to whole number analogies. And negative 21 divided by box equals 7 did not connect as well to a whole number analogy, but it almost seems as if it would be better to connect to another integer analogy. And Thank you so much for joining me today, and I'm sorry for that background noise. I'm not going to be re-recording this, and I think that you'll just stay around for questions now.